In our last video, we looked at this checkerboard and found a way for when the ratio was 2 of figuring out an explicit formula for the last square, and we also came up with a way of figuring out how many things would be on the entire checkerboard, and we went through a routine like this, an algorithm like this, to come up with a formula. But we also said that we could make the ratio that's in here anything. It doesn't just have to be 2. It could be 3, 4, 5. It could be a fraction. We're going to make it some ratio just called r. Is there a general formula that we can do for this? And I think we can come up with that general formula in the same way that we did this. So what we're going to do is we're going to, this time, make our sum equal to 1 plus r, that's r to the first, if you will, plus r squared, plus r to the third, all the way up through r to the n. Now last time I doubled it. What I'd like to do this time is multiply it by r, so that we get the same thing like before. R to the first, plus r squared, plus r to the third, and so on, up through r to the n, plus there's one more. If I subtract these now, I've got to make sure you can see it's one more. Yes, there's one more. One more. I'm going to subtract these. So what I have is r times s sub n minus s sub n. Here I have r to the n plus 1 minus 1. Now you notice you have an s sub n in common with both of these two terms here. So if I take out s sub n, I get r minus 1. Here I have r of s sub n's. Here I have one of them, or a negative one of them. So I get this. So s sub n is r to the n plus 1 minus 1 over the denominator of r minus 1. That's our general formula for working with these kinds of problems. These problems are called, the sequence is a geometric sequence, the series is called a geometric series, and this is the way things will change exponentially when you look at the sequence or when you look at how the sum works. Now we've derived a formula here, which is very useful. I think we need to know that it works in every case. So in the next video, what we're going to do is we're going to prove that this works by using mathematical induction.